Hi there. In this video, we're going to take a look at this Tokina lens, open it up, and see if we can fix a salt corrosion on the circuit board that is shorting it out. It is a Tokina AT-X116 Pro DX2. It has the EFS mount for a Canon camera. I used it on my T6i Canon, and it was primarily used for hiking. Great for getting nice wide angle shots when you're up on top of a high spot. One day I just went to turn on my camera with it, however, and completely dead. At first I thought it was a camera. I swapped out the battery, um, went through the standard troubleshooting and determined that it was a lens. Once I put on a different lens on the camera, everything worked normal. So I sent it into Tokina to see if they could fix it, and they did confirm it was saltwater damage. The price they quoted me was more than half of the cost of what it would take to buy a brand new one, and that was just too much for me, so kind of wrote it off, and it's been sitting in my closet for about a year. Figured I would open it up and see if I can get it working again. So now the short that it has is actually kind of intermittent. Earlier today, before I was prepping to make this video, I did I probed the contact points. Let's get the reference in here. And I have just a stock lens here that's a Canon as a comparison. So the short is intermittent. I did probe them earlier, and it was showing a direct short between the A ground and VDD, and then also VDD and D ground. And I was adjusting the lenses, kind of moving it around, wiggling it, just kind of take a look at it, get a preliminary idea of how to open it up. And after doing that, it actually knocked loose whatever corrosion there was, to where now there is not a short. So, I mean, we're still going to open it up and clean up any corrosion we can find, because obviously it's not something that's going to fix itself long term. So right there, kiloohms, and as a comparison on the Canon lens, we got 42. Earlier today, this was showing like 27 ohms, so it was almost a direct short. Now, I've never worked on a lens before, so this will be a new experience, and hopefully I don't make a fool of myself on this video by doing something stupid and breaking it completely. So we'll just start taking out screws and see what happens. All right, let's see here. Get a peek in there at the circuit board. Looks like there's a ribbon cable connecting this connector to the board, and we're not going to be able to just pull it straight out. Oh, I bet that connector comes out right there. So it looks like there's two little screws that hold that connector, and then I bet that pops out, or pops in rather. So I think this inner ring probably is partially holding it in. So I'll have to see if we can pop that out to loosen the connector there. There we go. All right, that comes out, and the connector separates from the metal ring. Just for reference, the red dot will line up with the red dot there. See a little bit of corrosion on that resistor right there, but that's certainly not enough to short anything out. I guess we're gonna have to dig a little bit deeper. Let's see, we've got a screw on the PCB here. Use tweezers because my fingers are too big. Some very tiny screws. Alright, so it looks like the ribbon cables are going down and connecting to something else holding the PCB in, so we can't just pull that directly out. Same thing on this side. Looks like we can probably get this ring off. It'll give us a little more access. Alright, when I'm taking screws out, I always like to kind of set them in stages so that it's more easy to remember which way they go back in. And just for reference, the red dot is going to line up with the AFMF markings on the body. It looks like there's a little bit of a groove right there that goes around this metal piece. And then also you'll have the 3 holes line up of the screws you took out. So let's see how we can get this board out of here. Oh, yeah, I can see some corrosion already. Looks like that's a capacitor with quite a bit of salt around it. That very well could have been a source of shorting out. If that salt creates a conductive surface over the capacitor, that would definitely cause a direct short. So we need to get this PCB out and flipped around so that we can clean it up, and hopefully that's all it'll take. So let's see if this will come up at all. Oh, there's a screw underneath this ribbon cable here. You can see that. So in order to get to that screw, we would have to take this whole motor assembly out in order to lift that ribbon cable. I'm thinking I might instead just desolder that ribbon cable, undo that screw, and then that might allow me to flip the board over. I might have to desolder a couple ribbon cables here. I would rather do that than take the motor assembly out, because I don't know what kind of alignment issues I might have getting that put back in. I don't know if they use special jigs at the factory to make sure that these are in a certain alignment. Alright, so I'm going to get my solder gun ready and we'll pull that ribbon cable off. Alright, we are all set up to desolder this ribbon cable here. So I'm just going to use some soldering wick. I'm going to turn on the smoke absorber, so it might get a little loud. Help if I have it plugged in. I'm actually going to wet this with some fresh solder first. This seems to have a pretty high melt point right now. Trim that down a little bit. the second pass. I want to make sure I don't leave too much heat on here because I don't want to melt that ribbon cable. Let's see if I'll lift up. There we go. That gives us access to the screw right here. Let's see what kind of freedom that gives us to move the board around. Yeah, I'm feeling a lot of resistance from these ribbon cables over here. So I'm going to go ahead and remove those as well. Get them right off. Tuck this down inside so it won't get in the way. And then we'll go back and clean up the old solder with the wick. So there's definitely some nastiness going on there. And then on the bottom here, there's that capacitor that I saw from the side. It definitely has some corrosion on it. Other than that, let's look through some of the vias. There's a little bit of salt buildup. So we'll go through and just clean this. And wonder if we should dig any deeper. So I went ahead and completely removed the board from the lens, just desoldered the black and white wire as well as the last remaining ribbon cable, just so I can get it under the microscope more easily. So we can take a look at this capacitor here. That's where the most of the salt deposits and or corrosion is most obvious. There's also some here in like the little vias and just scattered about on the board. I don't think any of this here would be causing the short. Obviously we're still going to clean it up, but this is the main concern. The way it's kind of built up in the center there, it almost looks like the capacitor's cracked. Once we clean it, we'll take a look at it a little closer and see if we need to replace that capacitor. Alright, just going to put on some alcohol here, go over it with a toothbrush. Go over the other side as well, just to make sure there's none left over that I'm not seeing. This alcohol I'm using is 99.9% pure, specifically for electronics. You just use regular rubbing alcohol that has a higher water content, there could be deposits that'll be left on the board. It's looking pretty clean. I'm going to clean up around that capacitor a little bit more and then take a closer look under the microscope. So I did go ahead and remove that capacitor and clean up underneath it. I did verify that that white mark is just silk screen. I was concerned it might be salt underneath there, possibly shorting out the pads. So it's all cleaned up, got the capacitor put back on there. Just take a quick look around the board, see if there's anything else we missed. Looks like maybe just a little bit right there. All right, so I'll go ahead and prep these pads to solder those ribbon cables back on. Let's clean off some of that old stuff. And we can start putting it back together. Not spoke too soon regarding putting it back together. There is still some nasty stuff here we need to get off, and I'll just go over that with some alcohol, loosen it up, and then wipe it off with a rag. I think that should be able to get a lot of it off. Now looking down inside, I don't really see anything below that point down in here that looks like it could have the same issue. So this time I am not going to bother tearing it down any further. I'm going to see how it works as it is. I'm pretty sure that the main issue was just that capacitor had so much salt up around it that it was causing the short. See if we can scrape some of that off a little bit better. think that should be sufficient. Let's go ahead and put the screws back in to hold it in place while we get everything soldered. Right. Start with this side. Add a little bit more solder on a couple of these pads, make sure it has a good connection. Pull this ribbon cable out that tucked in there to keep out of the way. A little tricky getting this lined up. There we go. So we got good connections on all of those. Now move over to the other side here. And once you get just one pin soldered down, it's a lot easier to get the rest of it into place. Now for the wires. That one's pretty tight. Just barely reaches. See if we can get just the center pin attached, then we can work on holding down the rest in alignment. There we go. Alright, well that looks good. So we got some scratching on the lens. Not much I can do about that. Now if I can just remember the order I took this thing apart. Let's see, on this first ring here, we got quite a bit of salt down in there, so I'm going to give that a quick cleaning. I'm going to line up the red dot with AF, MF. And then these holes should line up with inside holes. There we go. That's where the screw goes in. Looks like this ring could use a little bit of cleaning as well. Also got the red dot there. Let us know which way to align it. That. So I guess we should screw in the connector here before we secure the ring itself. So there's a little dowel here which guides it in place on the outer ring. Get that dowel in there. There we go. And then now we put those two screws in to secure. We can put this inner ring in. It's a pretty snug fit. Curious if Tokina would have just replaced that board, or sent me a refurbished lens, or just cleaned it up like I did if I had paid them the full repair cost. Guess we'll never know. Hopefully this will be all it takes to get it running again. And I'll have to be more careful when I'm hiking and sweating a lot that I don't get any more salt water down in it. Still feels like it should. Let's go ahead and give it a test. And here we have the moment of truth. We'll go ahead and plug the lens in and see if it comes on. Hey, look at that. Well, there you have it. It's fixed.